Hi there. Today we are going to be estimating quotients using compatible numbers. So let's go ahead and put our title. Get out your notebook and let's write all about it. Estimate quotients using compatible numbers. Now, we've talked about compatible numbers before, but they really come in handy with division. When you estimate with division, now let's think back. What do we do when we estimate? We're trying to do mental math because we want to be able to, when we don't have a calculator handy, we know that when we estimate, we're supposed to be thinking of nearby numbers that are easy to work with so that we can think about what the real answer would be, and we can also use estimations to help us find out if our real answers, our real calculations are reasonable. So estimating quotients using compatible numbers is totally different than any of the other estimation we've done before. So I really need you to pay attention today. Okay, one of the big key things we will use, a strategy, is to use multiples of our divisors to help us find the compatible number. And that compatible number is going to become our dividend. I'll show you what this means in just a minute. Let's go ahead and write these notes real quick. So our strategy is to use the multiples of our divisors to help us find the compatible number, which will then become our dividend. You know, when we add and subtract and multiply using estimation, what we do is we round first and then we work the problem. Well, it's the same way with division. So let me show you an example. Like, say for instance, we had a problem. This is our first one in module 9.4. This is module 9.4. Our first one, what we're doing is we're taking the number 132 and we're dividing it by 3. Now at this point, we have not divided 3-digit numbers by 1-digit numbers, but we can use a strategy to help us figure this out anyway. So what is the first thing we do when we have a division problem? If we're dividing by 3, what can we do? We can write our 3s. So we're going to write our multiples of 3s. Let's go ahead and do that. We have 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. That's just a habit we need to get into. We're writing our multiples. Okay, so let's look at the first couple of digits here. 13. Well, if we had this number, what multiple is closest? We're looking for, when we estimate, we're looking for a number that's easy to work with. Well, 13 is not a multiple of 3, but let's find a number that's awfully close to 13 that is easily divided by 3. And I'm looking at these two numbers. We know that 13 is between 12, which is a multiple of 3, and 15, which is a multiple of 3. Now, which one of these multiples is closer to 13, which is our actual number? Well, you're right if you guessed 12. 12 is only one counting number away from 13. So let's change this. We're not working this problem. We are actually, we're estimating first, so let's change this to 12. Let's change our dividend to an easy number to work with, which is called a compatible number. Let's change those first two digits to 12 and then make it back into a 3-digit number. So you can see that 132 is somewhat close to 120. And we'll still divide it by 3. Now let's talk about this for a minute. Why wouldn't we use regular rules when we divide? Well, there's a lot going on with division. If we have 132, let's just say we rounded it to the nearest 10. Well, 130 is not going to be easily divided by 3. Because those first two digits, we've talked about dividing with zeros. 13 is not, it's not a quick fact with 3. We'd have a remainder, wouldn't we? So we want to find something that we can work with that will not have a remainder. This is going to be easy to work with when we're dividing by 3. So let's look at our quick fact. What's 12 divided by 3? Well, it's 4. And then what do you do with your 0? So look how easy that is to divide mentally. 120 divided by 3 is 40. Now if we actually worked out this problem, our answer would be somewhat close, but let's just practice some estimation first. Let's do another problem. Okay, let's do 467 divided by 9. Okay, now that looks kind of like a scary problem there, but it's really not when we're estimating. So I'll show you the actual problem this time after I work the estimate. But what is the first thing we do or can do when we're dividing a number? We can look at our divisor and we can say, okay, we're talking about groups of 9. Our divisor is our key. That's our key to understanding division and fractions. When we get to fractions, we know that division and fractions are the same thing. So we're looking at groups of 9. So if we're looking at groups of 9, let's go ahead and write our 9s. So this time I've used this space over here. Let's write our 9s over on this side. Remember, 9s have a really good trick. Let's do our 1s place going down. 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. And then let's look at our 10s place. It goes up 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you don't know your multiples of 9, you can easily start to learn them by practicing that skill. So we have 9, 18, 27, 36, 45, 54, 63, 72, 81, and 90. Now again, the reason why we're writing these multiples is so that we can think which one of these is a close nearby number that is easily divided by 9. And a multiple of 9 is going to help us do that. So let's look at the first couple of digits. We have 46 going on here. Okay, so let's look down our list of multiples. Which one is awfully close to 46? So we can keep on going, keep on going. Now 45, our number of 46 is between 45 and 54. So here's 46. Which one is closer, 45 or 54? And I mean, if we put this on a number line, 45 is awfully close. It's only one counting number away from 46. So let's go ahead and use 45 as our basic fact. So let's change our original dividend to 45, and let's add that 0 at the end to make it a 3-digit number, just like this one. So if you look at it now, isn't 467 somewhat close to 450? It is. So we think we're going to come up with a reasonable estimate. Now let's divide that by 9. Again, we practiced these with zeros. Let's look at the basic fact. 45 divided by 9 we know is 5. 1, 2, 3, 4, 5. So let's write our 5 up top and our 0 comes up. So we know that 9 times 50 is 450. 450 divided by 9 is 50. Now that is a quick an easy answer because what we did was we found the closest nearby multiple of 9, which is 45, and we don't have any remainders. That's the whole idea. We don't have any remainders. It's easy to do in our head. It's for mental math. Mental math. That's the whole point. I'm going to work this long division. You have not learned this just yet, but 9 goes into 46 5 times. We know that. 9 times 5 is 45. We can take out the part we put into groups. 6 minus 5, that would be our leftover. If we were working this in class, we would know that. That's the part that we've been able to do so far. We're just going to go one more step. We have another number to work with. I'll bring down my 7. Now I have 17 to work with. So I go down my list of multiples. If I only have 17, can I put 18 into groups? I cannot. I can only make one group of 9. So that's what I'll respond to up here in my quotient. 9 times 1 or 1 times 9 is 9. Of those 17, I could put 9 into groups. 17 minus 9 is a quick subtraction fact. It is 8. 8 is smaller than our divisor, so we have a remainder of 8. Now, wow, look at this. If I worked the actual problem and the estimate by finding the closest nearby multiple, they are very, very close. So it is reasonable. We're going to work another one. Okay, are you ready for this? We're going to do 276 divided by 7. Okay, remember, if we're dividing by 7, let's write our 7s. Let's write our multiples of 7. So we have 7. 14, 21, 28, 35, 42. Now we can stop there because remember, we're looking at the first couple of digits. We're saying, okay, let's think about making a new number that we can work with easily when we're multiplying by or dividing by 7. And actually multiplying because we're finding multiples to help us divide. So let's look for a close nearby number to 27. Okay, so we have 7, 14, 21, 28. Now let's think about what 27 is between. 27 is between 21 and 28. So remember, we're not working the actual problem. Now before we'd say, well, we don't have 28. You're right. You're absolutely right. We don't have 28. But remember, when we're estimating, different rules apply. So we're thinking about a close nearby number. Now which one is actually closer to 27? Is it 21 or is it 28? 28 is only one counting number away. Now even though it's more than what we actually have, that's okay because remember, we're estimating. So let's pick 28. 28 is one counting number away from 27, and since it's a multiple of 7, we can easily divide by 28 when we're working with 7. So 280 is what we will use now. So we've changed 27 into 28. We've added a 0 to make it a hundreds place number. We're still dividing by 7. So let's look at our basic fact. 28 divided by 7 is 1, 2, 3, 4. And what do we do with our 0? Easy. We bring it to the top. We know that 7 times 40 is 280. Remember, this looks just like our little area model, doesn't it? And if I worked this actual problem, I would come up with an answer that's close to 40. And that way I'll know that my answer is reasonable when I do my actual division. Now I will do this. If I'm working the actual problem, I don't have 28, but I do have 21 I can put into groups. So I'm going to say that that's 3. 7 times 3 is 21. I'd have 6 left over, and I bring down my 6. Oh, 66. I need to go for it farther. Here it's 49, 56. Okay, so I know that I have 66. I'm going to use 63 because remember that's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 groups of 7. Uh-oh, look, isn't 39 awfully close to 40? We have 63. Our remainder is 3. If I have 39 with a remainder of 3, that's very close. It's almost on the way to 40. So you don't have to do this yet, but that's what we're getting to. We're going to start with it by finding out what we can do that's reasonable. Now let's make it a little bit bigger. We can do another one. So get your pencil ready. Let's do 2,000. We're going to get into the thousands. Let's just go for it. 2,872 divided by 5. Good. Thank goodness, 5s. Now remember, if we're dividing by 5, we write our 5s. Let's go ahead and do that. That's 5, 10, 15, 20, 25, 30, 35, 40. We don't need to go any further. Let's look at our first 2 digits. Okay, so we're looking for a multiple of 5 that's close to 28. Okay, so that's closest to 28. So we know that 28 is between 25 and 30. Now this one's a little bit harder because let's look, it looks like it's kind of somewhat in between. 25 is 3 counting numbers away from 28. 30 is only 2 counting numbers away from 28. So both of them are going to give you somewhat of a reasonable estimate, but which one is actually closer? It's 30. It's only 2 counting numbers away. So you're going to get a better estimate for that. So let's go ahead and change 28 into 30. And this time it's a 4-digit number. So how many zeros do you think we're going to need to add? We need 2 more place value positions to make this number similar. So our basic fact now actually becomes what? 30 divided by 5. And that's so easy. We know that because 30 is a multiple of 5. 30 divided by 5 is 6. 1, 2, 3, 4, 5, 6. And what do we do with our extra zeros? We float them to the top. So our estimate is 600 as our answer. If I worked the actual problem, it would be awfully close to this, but we'll save some time and we'll work one more problem. I keep saying that, but we're going to work one more problem, and then I'll let you go on your own. Okay, so let's look at 963 divided by 4. Now this one's a little bit more interesting. Okay, first of all though, what do we do? If we're dividing by 4, we write our 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. That's good practice anyway. Okay, so this time, usually we're looking at the first two numbers, but let's look at the first number. What is a multiple that's awfully close to 9 when we're working with 4s? It's 8, isn't it? 8 is one counting number away from 9. So we know that 8 is larger than 4, 9 is larger than 4, so we can look at that first digit this time and say, okay, let's change that into an 8. It's not closer to 12. 12 is the only other nearby multiple that's between, or 9 is between 8 and 12, but 12 is the only other multiple we could use that would be reasonable, but it's only one counting number away from 8, so let's go down. Let's round down in this case to 8. Our divisor is still 4, and we need 2 more place value positions there. So we're going to change this to 800 because it's easily divisible by 4. So what is 8 divided by 4? It's 2. And what do we do with our other zeros? We simply put them up top. Okay, that's what we'll be working with today. I hope this has made some sense to you, and we will work some more. Enjoy!